Homework 1.4, section complex numbers, video 6, homework due May 16, 2020. In the previous videos, we looked at number systems, we introduced, sets of numbers. We introduced a new set of numbers called complex numbers. We talked about how to do addition and subtraction and multiplication with complex numbers. And for this final video or two, if I feel like it goes too long, I'll cut it off and start another video. We're going to look at simplifying square roots and finally get to use this first statement that we said. If you see a square root of -1, you should change it to I. So on the board I have 6 examples of simplifying square roots, half of which will invoke the number I and the other half of which will not. I think it's pretty easy to see which is which based on the way I've set up the examples. But if you notice the 3 examples on the right side of the board, simplify the square root of -4, simplify 3 times the square root of -20 plus 7 times the square root of -5, and simplify 2 plus the square root of -12 over 2. All have square roots with negative radicands. The word radicand, R-A-D-I-C-A-N-D, is the word for something under a square root or something under a radical sign in general, whether it's a square root, cube root, or any other type of root. But on these, all of the radicands are negative, and those are going to invoke this statement about seeing a square root of -1 and changing it to I. But before we get to those, let's just review some simplifying square root problems that are involving real numbers because their radicands are positive. So let's start with simplify the square root of 20. Now, most of you know how square roots work. The square root of 25 is 5. Why? 5 times 5 is 25. Ooh, teacher, mark your fingers. What about something like the square root of 20? And if you put that in your calculator, it will probably tell you something like 4.48 or something. Go ahead, you can check me. If it's not that to 2 decimal places, it's pretty close. But when you simplify a square root, the objective is to do as much of it as possible without resorting to irrational numbers. In other words, do as much as you can short of getting a decimal that goes forever and never repeats. So how can we simplify the square root of 20? Well, one trick to simplifying a square root is to break it down into a multiplication problem, half of which you can square root. So for example, can you think of a multiplication problem equal to 20 where you can square root one of those 2 numbers? Well, there's really only 2 ways to break down a 20. You could say 2 times 10, or you could say 4 times 5. But I'm not going to use 2 times 10 because I don't know the square root of 2, and I don't know the square root of 10. So instead of having 1 square root I couldn't answer, I would have 2. But if you notice in 4 times 5, I do know the square root of 4, because 4 is a perfect square. So to simplify the square root of 20, I can break it down into the square root of 4 times the square root of 5. And then do the one that I know, which is the square root of 4. I don't know the square root of 5, so I'll leave it alone. So as far as simplifying the square root of 20, that's about as far as you'd be expected to push it. Now, there will be other places later on in this course where we run into square roots, and you will be expected to simplify them. So hopefully this is a skill you remember and can practice if necessary. Let's take a look at the second example that doesn't involve imaginary numbers or complex numbers. Simplify 4 times the square root of 25 plus 7 times the square root of 9. Well, I know the square root of 25, it's still 5. And we saw the square root of 9 in the previous video, it's still 3. So to do this one, you would follow the order of operations. You know, please excuse my dear Aunt Sally, which hopefully you remember stands for parentheses, exponents, multiplication, division, addition, and subtraction. It's the order in which you do arithmetic, the order of operations. Most people write it left to right. I prefer writing it like a totem pole, so you go top to bottom, and to emphasize that multiplication and division are the same level, meaning that you just do them left to right. You don't always multiply before you divide. Same thing with addition and subtraction, and please keep that in mind on those stupid Facebook memes that say, only geniuses can do this math problem. It's almost always one of these. Sorry. All right, so anyway, so we're going to follow the order of operations. You may be wondering, where do square roots fall in this? For reasons we'll see later, square roots are the same things as exponents. They really are. So I'm going to put comma square root there, which tells us that we do the square roots before we do the multiplying and the adding. So, square root of 25 is 5. Square root of 9 is 3. We've done the square roots. Now it's time to multiply. 4 times 5 is 20. 7 times 3 is 21. And finally we get to add. 20 plus 21 is 41. So pretty straightforward. Might not have even needed to go through this, but that's the correct order in which you do it. And you may be looking at the last one and say, what are you trying to do to me? Why do you want me to mess with this? The short answer, when we see the quadratic formula in the next homework, we're going to get answers that look like this, and we need to be able to simplify them. Now, there are some things people want to do instinctively here that they shouldn't, such as reduce the 6 and the 2. There's a way to reduce it, but you can't just reduce the 6 and the 2. There's a rule for reducing fractions, which you will hear me say anytime the opportunity presents itself. In a fraction, you can only reduce parts of multiplication problems. Let me say that again. In a fraction, you can only reduce parts of multiplication problems. And the reason is really easy. It's really intuitive. A fraction is a division problem. And what's the opposite of dividing? Multiplying. You know what's not the opposite of dividing? Adding. Things cancel when inverse operations meet. Adding and dividing are not inverse operations. They don't cancel each other. This 6 being part of an addition problem is not eligible to reduce in a fraction. So again, in a fraction, the only things you can cancel are parts of multiplication problems, not parts of addition problems. That doesn't mean we can't simplify that. That just means we need to be a little more careful. So let's start with the square root of 12. Now we can kind of do the same thing we did with the square root of 20. We can break off a piece of it. So what multiplication problem do you think I can break 12 into so that I can square root a portion of it? Not 2 times 6, I don't know either of those square roots. But 4 times 3 will work because I know the square root of 4. The square root of 4 is 2. So the square root of 12 simplifies into 2 times the square root of 3. So our first move is to write this as 6 plus 2 times the square root of 3 over 2. Oh look, there's more 2's. Let me cancel those. No, for the same reason. This 2, although it is part of this multiplication problem, is still part of this addition problem and is not eligible to cancel. But look at all that stuff that wants to cancel. I know, but you can't break the rule. But you can work around it. There's a couple of ways to reduce this properly, but I'm going to show you the easiest way. The easiest way to reduce a fraction like this is to split it into 2 smaller fractions. Recall the rule for adding fractions. Get a common denominator and then put the numerators together. Well, if I can put them together, can I take them back apart? In other words, I can unadd this back into 6 over 2 plus 2 squared root of 3 over 2. Just by unadding it and keeping the common denominator. Now the advantage to that is it removes the plus sign from inside the fraction. There is nothing preventing me from reducing that first fraction, and there is nothing preventing me from reducing that second fraction. So again, the rule for reducing in a fraction is you can only reduce parts of multiplication problems. Or more specifically, you cannot reduce part of an addition problem inside of a fraction. So by splitting it into 2 fractions, the addition is no longer inside of either fraction, and I can reduce both of them. 6 divided by 2 is 3. In the second fraction, the 2 on the top is now part of a multiplication problem only. It's no longer part of an addition problem. The 2 is eligible to cancel, the 2 2's cancel, and we get the square root of 3, and that would be our best answer. So again, we're going to run into situations like this in the next homework, so I wanted to lay a foundation now. Don't worry, we're going to see it again over there. I'm just going to check the time on the video, get the feeling. I might want to pause this and have a part 2. Yeah, we're at the 9-minute mark, so let's go ahead and pause this and we'll do a part 2, and the next video will be the last one in this series.